In this problem, what we're trying to do is we have two different things going on. We have the evaporation of 50 grams of water. The evaporation of 50 grams of water is an endothermic property. So it takes energy to evaporate a certain amount of water. And that water, the energy coming from that evaporation is coming from the process of cooling a certain amount of water a certain temperature. So we have two things going on. We have water cooling from 35 to 22, and that energy is going into evaporating the 50 grams of water. So we have one exothermic process, or an exothermic process, the water cooling from 35 to 22. That amount of energy is going into evaporation of a different sample of water. So it's just a sort of a first law of thermodynamics. So for the first step, we're trying to figure out how much water we have to cool to evaporate, or coming from the evaporation of 50 grams of water. So the thing that we know everything about is the evaporation of the 50 grams of water. So we can figure out how much energy it sort of takes to evaporate the 50 grams of water. The way we need to figure that out, well, it's an evaporation, which is a phase change, and we are given the enthalpy of vaporization, vaporization, same thing. We are told that it's 2.4 kilojoules per gram, and we know that it's 50 grams. So that's just the enthalpy of vaporization times the mass. So that will give us tells us how much energy we're sort of getting to play with, if you will, in this case. How much energy it takes to evaporate all that. And all that energy is coming from this 35-degree water turning down to 22. So once we know what that energy is, let's just say that the energy needed is equal to X. All right, so X is then also equal to the energy removed from the water, the other water, going from 35 degrees to 22 degrees. So we now have a sample of water in the specific, so we need to figure out how much energy does it take to cool a certain amount of water from 35 to 22. Well, that is the amount of energy needed to cool anything. Energy cooling water is equal to the specific heat of that water times the mass of the water times the mass of that water times delta T. So and of course that's equal to X in this case. So we know what delta T is. We know what delta T is because we're going from 35 to 22, so delta T is 13. The mass, and we know what the specific heat of the water is, because we're told that's 4.184. We know what X is because we figured that out from before, and so what we were being asked for is simply to solve for the mass of water. Hopefully that makes sense.